All right, we're live. Here we go. So today we're looking at absolute value inequalities. We're gonna need 10 boxes today. You can make 6 on the front, 4 on the back. We're looking at absolute value inequalities. This is going to be the blend of what we learned last time, the absolute value equations, and the compound inequalities that we learned about a week ago. Okay, so we're putting them together and we're solving these kind of crazy looking things as absolute value inequalities. All right, so this is going to be should be brand new. Okay, brand new. So an absolute value inequality is nothing more than just a compound inequality. Okay, but the only thing that we have to do different is we have to make the conversion. We have to write it in a different way. Okay, so we're gonna make a note here. All right, so when solving absolute value inequalities, we must convert into a compound inequality. Okay, and just like before, we had two cases. Okay, the first case is when the inequality points toward the absolute value. When that happens, that means that we have an and inequality, which means that we're going to have to create a sandwich. Right. So this represents and. Okay, so highlight this. If it points towards the absolute value, then you get an and problem. So then the other case has to be if it points away, right? So it could be a less than or equal to, but you're just looking at the direction of the arrow, okay? So if it points away from the absolute value, then that becomes an or type inequality. Okay, and or inequalities can become a little bit tricky when you're dealing with absolute value. All right. So we're looking to see which case are we going to need to use. All right. Okay. So first example here. We have absolute value of 2x plus 7 is less than 11. Okay. So last time we dealt with equals, right? We had an equal sign here, and we would split the equation into two, and then we would solve. Okay, we talked about that not last time, but the time before, last week on Thursday. Okay. When you have an inequality now, it becomes a little bit tricky to read, but remember that absolute value is a distance, right? Absolute value is distance. So now what we're saying is that the absolute value, the distance has to be less than 11. So what numbers can I plug in for x that will allow me to keep this number to be less than 11? Okay? The distance, how can I keep the distance to be less than 11? Okay, so remember, if it's a distance, okay, just to give you a picture, and the reason why these end up becoming compound inequalities is because if I have a distance and I want to keep it to less than 11, it's not just between 0 and 11, it can also be between 0 and negative 11. Okay, so the distance is almost like a radius, right? I can move like 11 spaces away on either direction, right? As long as I'm within that space, I'm okay, right? So that's why these absolute value equations become, or these inequalities become compound inequalities, all right? So watch what happens next. Okay, I'm going to erase this. You don't need to draw this. I was just showing you. This is what happens when you have an and, right? This is an and inequality because it's pointing towards the absolute value, okay? Towards the absolute value, I turn this into an and problem. It's real nice because it becomes a sandwich problem. Watch what happens. We're going to keep the 2x plus 7 in the middle, and you're going to keep the less than 11. You create the sandwich by copy pasting the same inequality on the other side, and instead of 11, what do you think? Negative 11. Just like that. So now we're back to where we were 2 weeks ago. Okay, compound inequalities, right? So just being able to write it. Okay, but now remember, this tells you that whatever x value is, it has to keep me between negative 11 and 11. That's all. How do I maintain my distance so that I'm within 11 spaces away on either side? Okay, so from here, business as usual. Okay, subtract the 7 from all three sides. That's going to give us negative 18 is less than 2x, which is less than 4. Okay, so finally, you divide both sides by 2, and we get negative 9 less than x less than 2. Okay, so how does this work, right? What does the answer mean in terms of the problem? It means that if I pick an x value that is anywhere between negative 9 and 2, but not including negative 9 or 2. So for example, let's say 1. Right? If I pick 1 and I were to plug it in for x, well, that gives me 2 times 1 is 2, plus 7, that's 9. The absolute value of 9, is that less than 11? Yes, it is. Okay, so then now instead of only getting 2 answers like we did before when there was an equation, now we have a whole range of answers. Okay, so we have any answer in between negative 9 and 2, but not including these numbers, that if you plugged in here and you took the absolute value, it would be less than 11. Okay, all right. So from here, remember, this is answer number 1. Then we have the graph, and then we have to write the interval. Okay, so it gives us more practice to get used to this because, right, that was one of the things that we had a little bit of trouble on, writing the correct notation, right? The parenthesis, the bracket, which one? Okay, so from here, let's go ahead and draw number line. Here's 0, here's 2, here's negative 9. Okay, at negative 9, open or close circle. That's an open circle, yep. What about at 2? Also open. Where's the shading going to be if it's an and problem? Or where should it be most of the time? In the middle, right? Well, let's just double check, right? It's got to be less than 2, so over here, and greater than negative 9 this way, so it's going to fill in the center, okay? So I get my shading right here. Okay. Because that's my solution set, right? This is number 2. What's this interval going to look like? At negative 9, I have an open circle, so what does it start with? It's a parenthesis, okay? So for part 3 of your answer, we have a parenthesis, negative 9, comma 2, parenthesis or bracket. Parenthesis again. Okay, there it is. That's it. Okay. So the only thing new now is instead of splitting it, now you rewrite it as a compound inequality. Okay. So the and ones are actually really nice. The and ones are really easy. The or ones is a little bit more tricky. Okay, but let's practice a couple more and inequalities. Any questions on this first one? All right. Cool. Let's move on. Example 2. Absolute value of negative x. Wait. Plus 5 is less than or equal to 6. Okay. So the first thing you want to do is, where is the arrow pointing? Towards the absolute value or away from it? towards. So you go back up. If it's a towards, that means it's an and problem, which means we create a sandwich. Okay, create a sandwich. All right. So down here, I copy everything that I have. Negative x plus 5 less than or equal to 6. But now I need something on the other end. Right? So what do we do with this inequality? Copy and paste. Okay, so now we reuse the same one, right? Especially because since this includes, right, the less than or equal to 6, then on the other end it has to be the same. Okay, copy and paste. And then what's the value that we use? Negative 6, yeah, that's right. Okay. Okay, so then from here, right, pretty simple. What do we do first? Subtract the 5, all right. Okay, so subtract 5 from all three sides. That's going to give us a negative 11 less than or equal to negative x less than or equal to 1. Okay. All right. Now I want to free up my x because it's being multiplied by a negative. What can I do to all three sides? Divide by a negative 1. Good. Okay, so let's go do that. Divide by negative 1. Okay, so my values, I'm going to get 11 here. I'm going to get a positive x here. And then 1 divided by negative 1 becomes a negative 1. Okay, but what happens to both of those inequalities? Now they flip back. Okay, so they got to flip the other direction. So now, okay, they both face that way. All right. Notice something when you have and inequalities, and this goes back to your quiz from the other day. Notice that whenever you have an and inequality, regardless of which way they're pointing, they both need to point in the same direction. They're both pointing left. Here, they're both pointing right. If you end up with an and inequality where one points to the left and then the other one points, one points to the right and the other points to the left, then you're going to have something that doesn't make any sense. Okay? It has to follow both in the same direction. Okay? Whether they're both going left or they're both pointing to the right. Okay? So when you were writing your inequalities the other day for like problem number 3, right? Some of you guys were saying like the car could go faster than 65 but less than 45. It's like, well, how does that make sense? You can't do that. Okay, you can't be bigger than 65 and less than 45 at the same time. And that's because you had your inequalities, one pointed one direction and then the other in the other. So they were both like pointing towards x or both pointing away from x. Okay, so just keep that in mind. With and inequalities, they both got to point both left or both right. Okay. Okay. So from here, this is solution number, or that's part 1 of our answer. For part 2, our inequality number line. Okay. I have 0, I have negative 1, and I have 11. All right, so from here, okay, let's just double check that this is going to work out. X has to be greater than or equal to negative 1. So at negative 1, I want to make sure I have what kind of circle? Closed circle. Okay, that's going to be shaded towards the right because X is greater than. Okay, and then here at 11, also closed circle. X in this case is what? How would you read that? X is less than or equal to 11. Okay. Remember, you can always rewrite it if you need to, but that's x is less than or equal to 11. So now we shade left. That tells me I have an intersection right here between negative 1 and 11. Okay, so let's redraw that. Okay, so finally, what's this interval going to look like? Bracket, negative 1, comma, 11, bracket. Good. That's it. Okay, so now what our solution tells us is any numbers including negative 1 all the way up to 11 and including 11, if I were to plug them in for x and I take the absolute value, they're going to be a distance less than or equal to 6. Okay, that's what we'll get. All right. Questions there? No. Okay. All right. How about this? Whiteboard time. Grab one. Try to do this one on your own. How do you know? Oh, you're waiting for it. Okay. Okay, before you guys start doing all the work, okay, just pause and think for a second. Okay, think about this. Think about this. All right. What did we talk about last time? Absolute values must produce what? Positive outputs, right? Absolute values can only produce positive outputs. All right, now think about it. Okay, think about it. I'm asking, what numbers can I plug in so that when I take the absolute value, the output ends up being less than -7? Is that possible? No, right? Right here you got no solution. That's correct, okay? So I was trying to trick you, but then he like shouted it out to everybody. So I can't have this. Okay? I cannot be less than a negative number if this never generates, this will never even generate like -1, right? This is asking me what numbers will it generate, right? If I plug in something for x, I take the absolute value, it's going to end up being less than -7. Well, it can't give me any negative numbers. Okay? So in this case, it's a no solution. All right. So no solution. Okay. On the graph, nothing gets filled in, right? Because there's no solution, no possible x values that could make that work. Okay. And there's something called, this is again, I'm trying to think back to my college days. There is something that you write in terms of an interval when there is no solution. I think it's an empty set. I think it looks like something like this. It's a set with nothing inside. It's an empty set. Okay. All right. So there's a college math tidbit right there. Okay. Empty set. Why? Because it's a set of solutions where nothing is inside. Okay. So it's like all real numbers. It's like the opposite of that. Okay. Empty set is the opposite of real numbers. Okay, I'll confirm that. I have a textbook at home, but I'm pretty sure that this is what it looks like. Or it's something called the null set, N-U-L-L, the null set, which again kind of means the same thing. It's a set that is empty. Okay, but just in, I don't know, in case you were curious. But this is good enough. No solution. Okay, just recognize it. All right, just recognize it. Okay, so pretty easy enough. All right. Let's move on to example 4. Okay, so let's take a look at, now we're going to take a look at an OR type of problem. Okay, with OR, there's more things to keep track of. There's signs that flip, signs that change. Okay, there's a lot of moving parts. Okay, so the AND problems are kind of nice, right? So if you see one, smile because it's going to be easy. If you see an OR one, okay, there's a lot more to keep track of. So take a look at this example here. We have 3x minus 2, absolute value of 3x minus 2 is greater than or equal to 8. Okay, so now, right, just like before we were saying, if it's an absolute value, then that means it's a distance, and we wanted the distance to be less than, right, like when I went up here and I showed you guys that little graph for this one, and I said, if it's less than 11, then I want a number line, I want to stay between 11 and -11, right, and then I kind of drew in the middle. Okay, now when it's OR, think about this, right? If it's OR and I want the distance to be greater than or equal to 8, just imagine kind of what's happening. If it's a number line and here's 0, I want my distance greater than 8. So if this is 8 and that's negative 8, then I'm looking for distances away, right? Further away from 0 than 8, right? So I could be 10 away, I could be 12, I could be 30, I could be 50, I could be 100. Okay? So as long as my distance is greater than that. So that's why this turns into an OR problem, because I want my distance to be further away from 8. Right? So if I'm inside that distance of 8, that's not what I'm looking for. I want to be away from this. Okay? So this is why it turns into an OR inequality. Okay? All right. So from here, okay, here's what happens. OR inequalities split into two. Okay? The first one, very similar to equations. It's the original. It's the OG. Okay? So we keep this. 3x minus 2 is greater than or equal to 8. Okay? So we're going to split into two inequalities, right? Just like when we looked at OR inequalities before, you would have this or this, right? You always had two. So that's the first one. That's the original. All we did was we copy pasted the inside, and then we brought down the inequality and 8. Okay? All right. So let's see. First is the original. Okay. All right. Now the second inequality. You have to flip the inequality and change the sign. Okay, so it's a two-part thing. So for the second inequality that you're going to draw, okay, you're going to do two things. Part A, flip the inequality. And part B, you're going to switch the sign of the outside number. Okay, so switch sign. Kind of like what we did when we solved absolute value equations, right? First time we kept it, the next time we changed it to a negative. Okay, but in this case, you have to do one more thing, which is just to flip the inequality. Okay, so for the second one, right, it's still going to be 3x minus 2. But now my inequality, instead of pointing to the left, instead of pointing to the right, now it points left. And I'm going to change 8 into negative 8. Okay, so those are what the two inequalities will look like. The original, and then flip switch. Flip switch, flip switch. Okay, that's how I remember. Or if you want to think flip flip, or switch switch, whatever. Okay, but just remember that you change both. All right. Okay. From here, now it's simple. Now we solve. Okay. Or inequality, we solve both, we graph, and then we find the interval. That's it. Okay. But this is the tricky part. All right. Just splitting it up. Okay. So let's go ahead. Let's go through it. I want to add two. Question? No. Oh. So we end up with 3x greater than or equal to 10. Right, divide both sides by 3. X will be greater than or equal to 10 over 3. For those of you who are obsessed with decimals, this is 3.33, and it keeps going forever. Okay, approximately 3.33333333. All right. Next one, add 2. 3x will be less than or equal to 6. Negative 6, sorry. Divide by 3. So x is less than or equal to negative 2. Okay. So now let's graph. Let's do a different color. Here's 0, negative 2, and 10 over 3, it's around 3.33, so here's 1, here's 2, here's 3, a little bit more than that. Okay, we'll call this 10 over 3. All right, so at 10 over 3, open or closed, what do we got? Closed. And which way do we shade? To the right. Okay, x is greater than, so greater than 10 over 3 would be to the right. Okay. X is less than or equal to negative 2. Closed circle at negative 2. And which way do we shade? Left. Okay. And here's the part where you guys need to practice. Writing these intervals. Alright? So, try it right now on your own, without me. See if you can get it. Okay, and then we'll do it right now and you can check. Instead of this, what do we use? So you're telling me that it's shaded between 10 over 3 up to negative 2. You're saying it's shaded in between here. Close. Are you saying negative 2 is further down this way? And then it gets to negative infinity? This is the start, and this is where it ends. So you're reading from left to right. Yeah, so flip those around. Does that make sense? There's 6. Okay, so are you saying then that the interval where it's shaded is between here and here? Okay, so remember you should have 2. They're split apart. So, yeah, same thing right here. If you're saying negative 2, that means that your shaded area starts at negative 2 and then it ends here. Are you saying that? No, okay. So you got 2 different ones. One that starts here and then one that starts here and then goes there. How do you represent when the shading continues all the way over here? Think about it. Almost. What do you need in between? What do you need in between? Okay, what you got? Which one of these goes first? Which one of these goes first? This one? Yep. And then how do you show that they're connected? So there's a symbol that we use to show that they are together. It should be a U. Okay. What you got here? So you're saying it goes from negative 2 to 0. So the shaded area you're saying goes from here to there. It starts where? Yeah. Okay. What you got? Good. 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 Ah, almost. Yes, sir. Where is it? Okay, and how do you connect them? What symbol do you use? Is that a bracket or parentheses? And then is this a bracket or parentheses? What kind of holes did we use? That's a hole, right? That's not a hole. That's a solid, right? So then it should be 8. And then over here, what kind of symbol? What did we start with? It's less than or there you go. So then that changes this to a solid as well. Good. What you got? What's shaded? Okay, this half is correct. Okay, here we got some issues. You're saying from 2 to 8?
No, this is infinity.
That's an infinity? Okay, so you're saying it goes from 2 to infinity, so negative 2, from 2 to infinity? Where is it shaded from? Where does it start? Almost. What's missing? How do you show that you've connected this side and this side? Not a comma. It's a union. You. You too. I'm gonna mark that one. Okay, here's what you should have gotten, okay? Most of you are there. There's a couple of you though, we gotta talk about it. If the interval starts on the left, remember you're reading from the left to the right. So I'm moving in this direction. So if I see shaded over here, okay, and it kept going forever, then that tells me that my interval starts at negative infinity. Okay? Around infinity, whether positive or negative, you always use a parenthesis. When we get to negative 2, then you can go ahead and use a bracket because it's a solid circle. It's connected to another piece. So then in between this gap, we have to use a union. Do not put or. I marked or wrong on your quiz. Okay? Use a union because this is the correct terminology. I told you it's okay to use or if it's up here, but when it's here, this is how you need to use it. Then comes where you start up again. 10 over 3 or 10.33 with this little dash above it. You have to use the dash above it because 3.33 is not correct. That's an approximation. If you put the dash above it, then it's for short, right? Because the 3 keeps going forever, and that's how you indicate that this is 3 forever. Then, oh, that looks like 16. It ends at positive infinity, and then you close it with a parenthesis. Okay? Cool. All right. I feel like you guys are all good, like up to here, and then this is where some issues happen. All right. I do want you to try this one on your own right now. This is not a trick, I promise. Go ahead, do it on the whiteboards first. When you have it, show me. Okay, recognize what type it's going to be based on the direction of the arrow of the inequality. And that'll tell you where to go from there. the interval look like? Or you have the graph, but not here. Okay, I think everybody's got it. Do I need to do it? Yes? No? No? Nah, you guys got it. Okay. Alright. So let's move on. Let's do one more. Okay. Make sure you get that example down in your notes, okay, so you have an example of it. Yes, okay, but I believe everybody looks pretty good. Make sure that your interval towards the end, I'm gonna just write it down, should look something like this. Yes? Something like that. Okay. If not, then you made a mistake somewhere. Okay. Okay, while you guys are doing that, let's start example 6. Alright, what do you think? Right, example 6, what do your instincts tell you? What does remember this is distance. And we want the distance to be what? Always, right? In this case, we want the distance to be greater than what? Yeah, which ones? All of them? All of them? Oh, 3? I have a box of it. Not there's some in that bin in the back. Make sure they all work in that bin. Okay, so instincts. What is it? What are they telling you right now? You think it's a no solution? ¿Por qué? Because of the negative. But that was when we wanted the distance to be less than negative, right? What's different this time? Greater than. Is a distance going to be greater than a negative? Yes, always. Always, right? So watch this. If you can recognize this, then if it's always going to be greater than negative, remember, any number I plug in is going to come out as a positive output. And is it going to be greater than the negative? Yes, every single time. Doesn't even matter what number it is. All of it could add up to be 0, and 0 is still greater than negative 2. Okay, so this is the opposite of a no solution. This is where every number is going to work. Now, if you don't see it right away, you can still do the algebra, and on this one, it'll work out. Okay, so watch this. It is going to be every single solution, all real numbers. Okay, but in case you don't see that and you accidentally like jump into the problem, you should still get back to all real numbers. Okay, so watch this. We can still solve it algebraically. Negative 3x minus 4 is greater than negative 2. Remember that you keep it. And then what do? What's that two-word combo? Flip and flip switch. Okay, flip switch. So negative 3x minus 4. Flip this guy, switch that guy. And now we solve. So watch this. Add 4. Whoops. Don't move. Add 4. Negative 3x greater than 2. Divide by negative 3. So x. What happens to my inequality since I divided by a negative? Flip it back. Okay? Flip it back, and I end up with negative 2 over 3. So x is less than negative 2 over 3. Okay? On the other end, I add 4. Negative 3x less than 6. Divide both sides by a negative 3. X has to be, in this case, now I flip. Greater than negative 2. Alright, so watch. When I graph this, remember that this is an OR problem. So I'm not looking for the intersection. I'm just looking to see how much of the entire line it covers. Okay? So here is 0. Here is negative, let's call this negative 1. This is negative 2. And negative 2/3, this is approximately negative 0.666. It keeps going. Let me zoom in on that. Alright, so let's see what this fills up. Alright, remember, OR, so we're looking for a union, not an intersection. Right, so at negative 2/3, it should be right before we get to negative 1. Negative 2/3. Okay, open or close circle at that value. Close. Open. Come on. Open. And which way do we shade? Beyonce. Okay. And then at negative 2, what do we got? Open circle. And which way do we shade this time? To the right. Okay. Now, union problem. Remember, union problem, not intersection. If it was intersection, then I would say just right here. But it's a union. So I want everything that is shaded. Okay? So we talked about this last time. It was a special case when we did compound. If it's shaded all the way through here, okay, but then I look down and that's shaded, right, it counts. Okay? So then I can keep going. So the entire graph is filled in. And when that happens, what do we say? Infinitely many solutions, all real numbers. Okay, in this case, we're going to say all real numbers. All right, so we use that special R. Okay, all real numbers. Okay, and that makes sense because if I go back, I just need a number to be positive. Any positive number is going to be greater than negative 2. Even if it's 0, 0 is greater than negative 2. So then any number I plug in for x, regardless of what happens on the inside, the absolute value turns it back into a positive, and positive always is greater than a negative. So we get it all real numbers. Okay. So I would put a star next to this one. Okay. Because if you can identify it and tell me all real numbers, then you don't have to do any of that work. Okay? Because then you're showing me you understand the concept of what a distance is, and distances can be greater than negatives. However, understand the difference here, that the distance cannot be less than a negative. distances are always positive. Absolute value cannot give you a negative number. There's no way you're going to get something smaller than -7. Okay. All right. Let's try another special case here. Okay. What if we get an absolute value greater than some expression? Not a number, right? An expression. Kind of like what we looked at when I showed you guys the multiple graphs, where they intersected, that kind of thing. Right? I want to know where the absolute value of x plus 5 is going to be greater than y equals x, okay, basically. Right? So, in this case, business as usual. What kind of inequality, which way is it pointing? Towards absolute value or away? Away. So what do? Sandwich or split? Split, okay? So we split regardless, okay? What's the first one look like? OG, okay? So x plus 5 greater than x, okay? Second one, what do we need to do to it? Flip switch. I like it. Okay, flip this guy, switch this guy. Okay, so now it's less than -x. Okay, all right, who cares? Keep going. I have x's on both sides, so what? All right. On this one, I want to get the x's together. Okay, put the x's together. So I'm gonna move this x, subtract x on both sides. Okay. This cancels. I get 5 greater than x minus x. I don't want it to cancel this time because I actually want a value here. I don't want 5 greater than nothing. What does that become? 0. Is that a true statement? Yeah. Yes, 5 is greater than 0. Okay. When you get that, what does that usually tell you? Take that bit. When you get a true statement. What if you got a true statement with systems of equations? What would you say? Pick an x value. Anybody? Pick one. Give me a value. What? 0. Okay. This side, 0. This side, 0. You're going to plug in the same number twice. But what does this one have that this one doesn't? You're adding 5. Is this side always going to be bigger than this? Yes. Doesn't matter what number you pick. Be 1,000. 1,005 is greater than 1,000. Okay? That's why this is always true. When something is always true, what does that lead to? What? All real numbers. Okay? Because you could have picked any single number in the world. Okay? Negative number. -5. Plug in -5 here, -5 here. -5 plus 5 is 0. 0 is greater than -5. So it doesn't matter, right? That's one way to see it. If we solve this one, okay, fine. It gives us a solution. But this one overrides it, okay? Because this is a graph of what? All real numbers. Okay, so you have to see that. When you get a true statement, you can then recognize this is all real numbers, infinitely many, what am I saying? Infinitely many solutions, okay? So, okay, they all mean the same thing. Okay, which means that the entire grid is shaded. All of it is shaded. What's a way to write an interval if the entire graph is shaded? What if I wanted an interval? Parentheses. Yep. Yep. Parentheses. Right? And remember that these two guys mean the same thing. All real numbers also represents this interval. Okay. However, if I ask for an interval, and I specifically ask for an interval, then I want to see this. Okay. You can write this somewhere on your paper, but just know if I say interval, I mean I need a start and an end. Okay. So this we didn't even need to solve, all right? Okay. Okay, a couple more questions so far. Okay. All right. Okay. Absolute value inequality, but with a bunch of junk. All right. Bunch of junk around it. Got to get rid of it. Got to clean it up. Just like with absolute value equations, what did we need to do first before we could split? Should I try to split this into and or yet? No. What needs to be cleaned up? The 2 and the -5. Okay, can I combine that and say that's -3? No. Okay, because this is being multiplied. -5 is being multiplied to this, but I cannot distribute, right? So then I have a free floating 2. I get rid of the 2 first. So, first move here, subtract that 2. Okay, we can bring down -5, absolute value of 10 minus 2m is greater than or equal to -30. Okay. Now at this point, again, this is why you do not split until the very end, because at this point, look at what it's telling you. This is an or problem, right? It's pointing to the number, not towards the absolute value. In this case, you could try to do it, and then it might actually work. You might think, oh, I could do it because it's greater than -30. All absolute values are going to be greater than a negative number, but you have that -5 first. So you clean that up first. Okay, divide everything through by a -5. Okay? And when you do that, this becomes 6. But what happens to that inequality? It flips. So now what you end up with is an absolute value of 10m, of 10 minus 2m, which is less than or equal to 6. And now what kind of problem is it now? It's an and problem. It's a sandwich problem. It's nice and easy. You don't have to split. You don't have to do flip switch. Okay? You just make that sandwich. So 10 minus 2m less than or equal to 6. But on the other end, what do we do with the inequality? Copy paste, right? It should look exactly the same. They should be pointing in the same direction. And what is going to be the value that's on this side? -6. Good. Oh, okay. So now we can solve and we can find out, right, what our m value can be. Okay, but just notice that it is possible to start with an or inequality, or at least it appears that way, and then it flips back into an and. Or it could do the other. You can do the opposite. It could start as and then you divide by a negative, and then it flips back. Okay, so just be aware that as you clean it up, you can split or you can sandwich once you have the absolute value by itself, the inequality, and then some term. Okay. All right. So subtract 10. That'll give us -16 less than or equal to -2m less than or equal to -4. Okay, look at all the switching that's happening on this problem. You're going to divide by -2. Okay, so when I divide by -2, what happens to my inequalities one more time? They flip. Okay, so we end up with m. This will be 8. This will be 2. This should flip. So now pointing in the other direction. So now we have something that says m is greater than or equal to 2 and less than or equal to 8. Okay. So let's graph it. I have 2, I have 8, M is sandwiched in between both, so I want to fill in the middle. Finally, create my interval. Question? Okay, so lesson here is be very, very aware of whenever you divide by negative to flip your signs. Okay, flip your inequalities. If you forget to flip one, the rest is off. Especially on a problem like this where they flipped twice, right? Back and forth twice. Okay. All right, you guys want like an actual hard problem? Legit? Yes? Okay. I'm not gonna help you with it, by the way. All right. Okay, here we go. Try this. This is a bonus. Whoops, not negative. Try that. I would do it on the whiteboard. And I'm gonna stop recording right here because